Alright guys, we're gonna go over the lab a little bit. Hopefully this was kind of fun for you. I was really sad because I was super excited to be able to do this in class with you guys. It's gonna be really fun. You're all gonna be able to do your own and see the reactions in front of you. Except for, of course, these last two. If you watch the video, you can tell why we weren't gonna do those in class. But hopefully you're able to do this lab. This is kind of gonna walk you through some of the answers. So for this first page, all of these things are based on completion, not accuracy. It says that down here at the bottom. And so just try your best. I just want to see that you're thinking about it, that you're trying to think through why these might be, stuff like that. The next page is going to help us see what the correct answer should be and what the science behind these reactions are and why they all have similar reactions with water. So I'm going to scroll down to now the second page. And so we see these pictures all up here. It's LINAKRBCSFR. So all these things, if you look back up here, are these that were in our reactions that we were talking about. You know, lithium is Li, sodium is Na, potassium is K, and so on. You'd also notice, if you were to look at your periodic table, I'll kind of draw a pretend periodic table right here, but pretend this is our periodic table. And stuff. And if you were to look at your periodic table, looks kind of like this, a really rough drawing, you would notice that right here in this column, we see Li, Na, K, and so on down the rest of the column. We see each of these in that column. So that's something to keep in mind as we're doing this. So let's look at the first question. It says, electrons in the outermost energy level or shell are called valence electrons. So let me show you kind of what that is with this highlighter. So this right here is our outermost shell. Okay, it's the outward one. It's not that inward one that's really close to the nucleus. It's the outer one. And so this is asking us for valence electrons that are in the outermost shell. Valence electrons are ones only in the outer shell, not in the inner shell. So lithium right here, it has this one valence electron. You notice it just has one valence electron in the outer shell. There's no other electrons out there. Lithium has a total of 3, but when it asks us for valence electrons, it's just 1. So if we do the same thing for sodium, or for Na, we can see that this outer shell, I'll highlight it again for you, this outer shell right here, if we go all the way around, we can tell this also just has 1 right there. 1. So we know sodium, if we counted up all the electrons, we would see that it actually has 11, but it has just 1 valence electron. So potassium, we do the same thing. We see it just has 1 right there, so it's just 1. Then rubidium also has 1. Cesium also has 1. Okay, I'll circle those for you. There you go. So we can see that this first column, group 1A, all have 1 electron in group 1A. So the next one is asking us, how many valence electrons are found in group 2 or group 2B? So this right here on your periodic table would be 2B. We could draw a similar structure if we wanted to. And so for that, it's BE. So we put BE in the middle. Around it, we'd have an electron, and in the outermost shell, we'd have another electron, another electron. It says, hint down here, if we add 1 electron and 1 proton to lithium, we would get beryllium. So if we're adding just 1 electron to lithium, you get this, and you can see that now it has 1 outer electron and 2 outer electrons. So it has 2 valence electrons. So group 2, or sorry, 2A, it's not 2B, 2A has 2 valence electrons. Now group 3, if we were to continue moving across our periodic table, we would add another electron to it, right? And add another proton, and we added another electron. We would actually change our element to be B, so we'd have B, and boron has 1 more electron than beryllium, and so it has 3 outer electrons. So by this point, you might be seeing the trend. As we move our columns, the number of column that it is, 1A, 2A, 3A, 4A, 5A, 6A, 7A, 8A, is how many valence electrons there are. So this one is going to have 4 valence electrons if it's in group 4. In group 5, it's going to have 5 valence electrons, 6 valence, and then 7, and then 8. So it's kind of cool that you guys can now know how many valence electrons, how many outer shell electrons are going to be present in a certain element based on its location on the periodic table. So that's a cool trick. The last question says, why do these elements in the same group or family have similar characteristics? So like we saw in the lab, they all reacted really similarly with water. And so this is asking us, why do they react similarly? And so this one, since we've been talking about valence electrons, we can see that all of these ones that act similarly with water that we did in the lab, what do they all have in common? So you can see that they all have the same number of valence electrons. So this would be, the answer would be same number of valence electrons. So that would be your answer for that one. We're going to be talking about this a lot in this class. That is how things react with each other. That's the properties that they have are a lot based on their number of valence electrons. So that's super important for you guys to know this concept. So hopefully this made sense. We'll be doing some notes on finding numbers of valence electrons and things like that. But hopefully you guys can finish up your lab and double check your answers. And I'll see you guys soon.